It says artisan. Okay. All right, guys. Today we are going to be talking about the wonderful subject of probability. Who can tell me what probability means? What's the English definition of probability? We have two numbers, right? Two numbers. So I could say the probability is A over B. What does A mean? I know, this is easy. Come on, what is A? What is A? The number of desired outcomes and what is the bottom number equal? The number of total outcomes. Okay, so this is what we call probability. So if I say that I have a probability of, let's say I'm shooting a free throw in basketball, right? I have a probability of 70% of making it. I'm good. I'm like Michael Jordan. And maybe 90%. This means that 9 out of 10 times I will make a basket. Now, we represent probability in a couple of different ways. Okay? We can represent it as a fraction, A over B. We can represent it as a decimal value, 0.90. We can represent it as a percent, 90%. Or sometimes we represent it as a ratio, A to B. So there's many different ways of representing probability. Now, I'm going to teach you guys something that you don't know. What is the difference between probability and odds? You guys know odds? Odds. You guys are, does anybody buy lottery tickets? Do you buy the Chinese lottery tickets hoping to get money? If you look on the lottery tickets, on the back of the lottery tickets at the very, very bottom, it says the odds of winning are A to B. So the odds are A over B. Let me give you an example. Okay, I'm shooting a free throw, okay? The odds of me making the free throw are 4 to 5. The odds are 4 to 5. Is that good or bad? Why? Why is that bad? Okay. The odds are just a little bit different than probability. Odds is, okay, A is the same. It's the number of desired outcomes. But B is the number of undesired outcomes. Okay, so odds and probability are just a little bit different. So, for example, if I say, okay, I have a 50% chance of winning. Okay? This is probability. Alright, so here's probability. 50% chance of winning. What are the odds of winning? Same answer. What means the same thing? 1, 2, 1. Those are the same thing. I can say I have a 50% chance of winning, or I can say the odds of winning are 1 to 1. You see the difference? Okay, so whenever we're talking about probability, especially if you're reading a book about probability, a lot of times we will see, sometimes it says probability, sometimes it says odds. So you need to know the difference between the two. Now, all right, we've got some definitions, okay? So here, let's do some definitions that relate to probability, okay? So our first definition that we want to do is biased and unbiased. Biased. Okay? say I have a biased coin. Heads, tails. What does that mean if I say it's biased? If I flip the coin, I get heads. If I flip the coin again, heads. Flip the coin again, heads. Heads. It's biased. What does that mean? Yes. So if I say I have a biased coin or a biased die, or something is changing the probability, right? So the probability of something happens is not consistent with what we think it should be. That's biased. So for a biased, it's the probability is altered in some way. Okay? It changes. We do something to the coin to make it where it's not 50%, right? So unbiased, of course, is opposite. Unbiased is is expected probability. Okay? It's what we expect to happen. I expect to get 50% heads, 50% tails, approximately, right? So that would be an unbiased die. All right, let's look at another definition. We've got set. Okay? Set. A lot of times when we're talking about probability, we say, okay, I've got two things here. I've got set A and set B. And I want to know what's the probability of something happening with both of those sets. Okay? A lot of times we use a graph to do this, but a set is just the possible outcomes together in one location. So it's just like, it's all the possible outcomes would be the set. So for example, we could say that S equals the set 1, 2, 3, 4. Okay, so S is the set of numbers. That means that these are all of the possibilities that I can have in my set. I can have a small sample of my set. So I can say that N equals the 2, 4. Okay, so N equals 2, 4 because that's a small sample of my set. Okay, now with set we have two operations that we usually deal with. We have intersection and union. So if I say A intersect B, you guys are familiar with this? Have you seen that before? Okay, that's intersect. That's what they have in common, right? I have set A, I have set B. What do they both have in common would be intersect. Or we could have union, where we have A union B. And this is what happens if I put the two sets together. Okay? So this is set theory. Okay? Some very, very basic ideas of set theory. And then finally, the last thing that we're going to talk about is, of course, a way to draw our sets, which is using Venn diagrams. All right. So Venn diagrams. So this is where I can look at, this is just an example. Here is set A, here is set B, and what would this area represent? What does this area mean? That is the intersection, right? So this area is A intersect B. Okay? So that's a Venn diagram so that I can see visually what all of my sets are doing, and then I can find the probability of something happening. So these are the things that we're going to talk about today. So, all right, let's look at a couple of examples. I want to look at a very, very, very simple example. example. And then we're going to try to get a little bit harder. All right, so all of you are going to be given this handout. Okay, so this is what we're going. These are the examples that we're going to be using today. All right. 2, 3, 4. 1, 2, 4. Uh-oh. 3. And finally, let's not forget you guys. Here's 2. Now, again, like I said, we're going to start off with very, very simple ideas. So let's look at question 1. Suppose an unbiased coin is tossed. Okay, we already know. What does unbiased mean? The chances of heads and the chances of tails are the same. Okay, so an unbiased coin is tossed. What are the possible outcomes? Heads or what's opposite of heads? What's the Chinese word? Heads, and what's that word? Flower? No, come on, I know. Tails, right? Heads and tails. Okay, so with a coin, we usually say, okay, this is heads, this is tails. If I flip a coin, what comes up? Okay. Now, all right, let's go to question 2. We're rolling a die. Let's say this is an unbiased die. Okay? What's the probability of rolling a 6? 1/6. Okay. Oh my gosh, you're smart. Okay. What is the probability of rolling an even number? 1 out of 2. What are the odds of rolling an even number? 1 to 1. Good job. Okay. Part C. What is the probability of rolling a prime number? Prime. Give me an example of a prime number. 2, 3, 5. There's 3 outcomes. How many total outcomes? 6. So the probability, 1/2. Now, we're going to get even harder. What is the probability of getting a prime number or an even number? 5/6. Why 5? 2, 3, 4, 5, 6. Okay, I'm going to get even harder. What's the probability? Listen, because this isn't on this sheet. What's the probability of rolling a prime number and an even number? Nope, not 2/6. Okay. Did you hear the differences? The first question. Listen. The first question, what's the probability of rolling an even number or a prime number? The second question, what's the probability of rolling an even number and a prime number? What's the difference between and or? Let's talk about or first. We've got 2 events. So we're going to say, okay, set A. Set A is the set of even numbers. Set B is the set of prime numbers. Okay? If I say A or B, the probability of A or the probability of B, what's the answer? We already said it. What's the answer? 5/6. Now, what about and? What happens if I say and? The probability of an even number and a prime number means that both have to happen together. How many do they have in common? Only 2. Only the number 2. So therefore the answer, 1/6. Okay? Now, guys, this is really, really, really important. Okay? Whenever we say or, and whenever we say and, these are 2 very, very important words when we're talking about probability. Now, let's go back to our idea of sets. What does that mean? How can I write the probability of A or the probability of B? What would I say if I want to write it all in one sentence? What would that be? Union, right? Union. I want to know what happens for A and B put together. Okay, so the word or means union. What does the word and mean? Intersects. Okay? So A and means intersect. Now, okay, let's go to cards for a minute, okay? I want to ask you guys an important question here, okay? You guys are familiar with cards, right? All right. Let's say, okay, we're going to go to a different example here just for a minute because I want to talk about, before we go to our next example on the sheet that I gave you, I want to talk about this idea of or and, or how to find the probability of A union B and A intersect. I want to focus only on this. Let's say that, okay, I have an 8. Okay, so let's say that set A is all 8s in the deck. How many are there? There's 4, right? Okay. Let's say that set B is the court cards. Okay, so set B is the court cards. This is the king, the queen, and the jack. Right? How many court cards are there? 12. Okay? Now, if I say the probability of A or the probability of B, what's the answer? How many cards are there? How many cards? 52. No jokers. Okay? There's 52 cards. So what is the probability of 8s and or court cards? 16 over 52, right? There's 12 here and 4 here. So the top number is the desired outcomes. 4 and 12 is 16. Okay, and the bottom number's here. Now, the probability of A. We know that the probability of A is 4 over 52. And we know the probability of B is 12 over 52. We know that the probability of A or B is 16 over 52. Right? Here's the question. Now, you have to think, because this is kind of hard. Is the probability of A union B, is this value equal to the probability of A plus the probability of B? Is that true? Is it true here? It's true here. Okay, it's true here. I mean, if I add these two fractions together, I get the answer. So I know that it's true for this example. Is it true for every example? What do you think? Raise your hand if you think the answer is yes, it's true. Nobody? Raise your hands if you think that is false. About half. Okay, what about the other half? Okay, well, can you give me an example? Can you give me an example? All right, let's change this. Let's change this to all jacks. Okay, this is just an example. How many jacks are there? 4. How many court cards are there? 12. What's the probability of a jack or a court card? Well, I mean, if I was going to count them all, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're missing some cards, so I'm just going to pretend like they're all here. 12. Okay? Why not 16? I've got 4 here, I've got 12 here, so why is the answer 12? Because there's some of them that are in common, right? So, how do I find the answer? Let's draw a picture, okay? This is where Venn diagrams help. This is why we use Venn diagrams. Okay, so I'm going to draw a picture here. All right. Okay, so here is set, oops, this isn't a very good. Alright, this is okay. Here's set A, here's set B. Okay, this is a Venn diagram. How many are in set B? 12, right? But how many are in set A? 4. And so over here, how many are in the intersection? 4. So if there are 12 here, there has to be 8 here and 0 here, right? So let's just see what happens. What if I said this? What if I said the probability of A union B equals the probability of A plus the probability of B? What happens? What happens if I take this value plus this value? I count this value twice, right? You see that? So this is not true. What would make it true? Minus what? Okay. If I count it 2 times, if I say this value plus this value, but if I counted this 2 times, I have to subtract one of them, right? So I say minus 1 of the intersection, A intersect B. And this is a formula that everybody needs to know. Okay? So, remember what this means though. This means or. So if I say the probability of A or B, it's the probability of A plus the probability of B minus the probability of A and B. You see that? Okay, so that's probability. All right, so let's go to our next question here. Okay, question 3. Now, this is a different type of question. Okay, if 2 dice are thrown together. Oh, no, I don't like question 3. We're going to do question 3 tomorrow. Let's go to question 4. I'm sorry. Okay, so here's question 4, and this is exactly what we were talking about here. We've got 3 different sets. Okay? The first set is epsilon. Okay, and it says, okay, set is the numbers 1 to 10. Set M is 1 to 5. Set N is 4 to 7. I want you, right now, to draw a Venn diagram that represents those 3 sets. Good job. Okay. So for a Venn diagram, okay, I want you to draw a box. Okay. Can you put that on the board for me? Okay, good job. Perfect. Okay. Did you get it right? Did you get the right answer? All right. There are three elements. Okay, we call them elements. There are three elements that are not in M and N. Okay, the three elements are 8, 9, and 10. So these go outside the picture. Now, I can use this picture to answer some questions. Okay? Question number 1. I picked a number at random, okay? What is the probability of that the number is in set M? What is the probability that the number I pick is in set M? What's the probability? One number, I pick it at random. What's the probability it's in M? 1/2. Good. What is the odds that the number is in M and N? What are the odds that the number is in M and N? This is a harder question. The odds that the number is in M and N. What's the top number going to be? How many numbers are in M and N? 2. The top number is 2. What is the bottom number? 8. 8. So the odds are 1 to 4. You see that? Remember, the top number is the number of desired outcomes. The bottom number is the undesired. So the odds that it's in M and N are 1 to 4. What's the probability it's in M and N? What did you say? Oh, I'm sorry. Yes, that's correct. 1 to 5. So the probability is 1 to 5. The odds are 1 to 4. Okay? Good. All right, now, let's look at number 5. Okay, and again, we did this already. Okay? It's the same kind of question. For an unbiased die, what is the probability of rolling a number that is either prime or even? What's the answer? The probability of prime or even equals the probability of prime plus the probability of even minus the probability of even and prime. Right? The probability of A or of prime or even. Probability of prime, 1/2. Probability of even, 1/2, minus the probability of even and prime, 1/6. The answer, 5/6. Okay, good. All right. And finally, let's look at question number 6. One card is drawn from a pack of cards. Okay, so we have a pack of cards here. What's the probability it's a diamond? One over 4, right? I've got 4 decks, four suits. Diamonds, hearts, clubs, spades. The probability it's a diamond is 1 out of 4. Okay, question 2. What is the probability it's a quartz card? 12 over 52. What is the probability it's a black card? 1/2. What's the probability that it's a 7 or a heart? This one's a little harder. What's the probability it's a 7 or a heart? How did you get that number? Let's write it down. The probability of a 7 or a heart. It's the probability of 7 plus the probability of a heart minus the probability of the 7 and hearts together. How many are there? 4 plus 13 is 17 minus 1 is 16. 16 over 52 is the answer. It's easy, right? Okay? All right. Good job. Okay, now, probability is fun. I love probability. Okay? But it does get a little harder. Okay? We can do the probability of one event. That's no problem. Okay, I don't know. We can do the probability of one event happening. That's easy. Okay, that's what we've been doing is one event. What happens if I increase the number of events? I flip a coin 4 times. What's the probability I have 2 heads and 2 tails? That's a little harder. Right? And I can make it even harder. I mean, what happens if I flip the coin 12 times? What's the probability I have 5 heads and 7 tails? Do you see how hard that's going to get? Okay, so what do? We need to, it's hard to see it in our head. So a lot of times it's easier if we can see a picture of all of the events that are happening. Okay? And this is the last thing that we're going to do today. I was going to do it tomorrow, but you guys are smart. You guys got everything else. So what we're going to do next, and this is the last thing, it's called a tree diagram. And a tree diagram helps us to look at what happens if multiple events occur at the same time. So let's just look at this. This is called a tree diagram. Okay. All right. Let's just do 3 times, okay? Let's look at what happens if we flip a coin 3 times. Okay, so what happens with the first flip? What are the possible choices do I have? Only 2. So I could have heads or tails. Okay? So let's just do that, okay? Okay, I get heads. Okay, I'm going to flip it again. Oh, I got heads again. You're right. So the second flip, I could have heads or tails. What happens if I got tails the first time? I could have heads or I could have tails. What is the probability? Let me just ask you this here. We'll talk about probability in a minute, okay? Now, the third flip. If I get heads first, heads second, what could I have on the third flip? I could have another heads or tails. I could have another heads or tails. From here, I could have a heads or tails. Here, I could have a heads or a tails. Now, this allows us to see every possible path that we could take. That's why we like tree diagrams, because it allows us to see the possible paths. So let me ask you this. What is the probability of 2 heads and 1 tail? Okay? Let's look at the tree. Okay, let's look at the tree. We want, remember that the top number is the number of desired outcomes. Okay, so here's one path. 2 tail heads, 1 tail. Is there another path? Where? Heads, tails, heads. There's another path. Tails, heads, heads is another path. Is that all of them? So what's the answer? 3/8 is my answer. So whenever we flip a coin, or whenever we have one event that's happening multiple times, a tree diagram will allow us to picture all of the possible paths that we can take. Now we can make it even harder. This is true if I have an unbiased coin. I'm going to make it harder. And this is what I want you to think about before our next class. What happens if it's biased? What if I get heads 75% of the time and tails 25%? Does that change my final outcome? If I have heads 75%, it's biased. Okay? It's a biased coin. I flip it, heads. I flip it, heads. Flip it, heads. Flip it, tails. It's biased. Does that change the probability of 2 heads and a tail? Yes, it does. Your question that you need to think about, how? How do I calculate the probability if it's biased? Okay? See you guys tomorrow. Thank you guys.